Adding and subtracting radicals. When we're adding and subtracting radicals, we're adding like terms. It's just now our like terms are going to be square roots or cube roots or something like that. All right. In order for them to be like terms, they have to have the same index, and what's underneath the radical has to match. Now, sometimes they may not match, and that's when you have to do a little work. If they don't match, you got to try to force them to match by doing what we did in the first two sections, simplifying. Now, if you can simplify these from the first two sections, this will be no problem for you at all. Here's an example of adding. The roots have to match. Notice both of these are square roots of 3. Okay, since they both have a square root of 3 only, they are like terms, and we add just the numbers in front. The square root of 3 is still in the problem. Just like if we were adding like terms with x's, the x is still in the problem. The square root of 3 is still in the problem. Let's say I had negative 4x to the 5th plus 9x to the 5th plus, not 9x, 9 times, sorry, negative 4 times square root of 5, 9 times square root of 5, plus 7 times square root of 6. This and this are like radicals. They both have a square root of 5 only. So, we add the numbers in front. It's still got a square root of 5. And then we put 7 square root of 6 behind it. I can't add these because they're not like. So this would be the final answer. Alright, let's say I had square root of 3x minus 17 square root of 3x plus 8 square root of 3. Now, I want to check to see if they're like terms. This is a square root of 3x. This is a square root of 3x. These two are like terms because they both have a 3 and an x. The third one is not like because it doesn't have the x underneath. So we're only going to do the first two terms, add the numbers in front, and the square root of 3x stays where it is. Then we've got 8 square root of 3. So you have to make sure the indexes match and that what's underneath matches exactly. Now, unfortunately, it's not always going to work. Let's say I had this, square root of 8 plus 5 square root of 18. Now, obviously, these do not match. So before you can try to add, hold on, let me get rid of this stuff. Before you can try to add radicals, you have to simplify them. At least try to simplify them. And they'll either match or they won't once you simplify it, but you got to go through the simplification process, just like the first two sections I did earlier. So we're going to take the 8, we break it apart, it's 4 times 2. Now, here's something I didn't mention earlier. This 8 is multiplied. When I take the square root of 4, I get 2. So I've got an 8 in front of the 2, square root of 2. You have to multiply those two numbers together in order to keep simplifying it. Let's do this one. 18 is 9 times 2. Got the 5 in front, I take the square root of the 9 and multiply the 5 and the 3 together. Now we can see that they match, so we're just going to add the numbers in front and we'll get this. That's my final answer. Let's say I had negative 3 square root of 75 plus 9 square root of 27. Actually, let's throw an X in there. Why not? All right. So let's try to break 75 apart. 75 is 25 times 3, then an X. Now I've got a negative 3 out here. I take the square root of the 25, which is 5. 3x is still underneath. Multiply those together. Get this. The 9, let's break it apart. 9 times 3 is 27. I can take the square root of the 9, so I got this 9 in front. Then we take the square root, and we get 3x. Multiply the 9 and the 3, we get 27. Square root of 3x. Now, I combine the negative 15 and 27. That's going to give me positive 11 square root of 3x. How about 12, not 11? 12. That's my final answer. So it's just splitting them apart to make sure that you can simplify it. Let's do one that's got a cubed root. So let's do 3 times square root of 16 minus 4 times the square root of 54. Now, not square roots. We're going to do cube roots. I said cube roots, didn't I? All right. Now, we got to know our cubes. And you got calculators. Don't worry about that. We can split 16 apart as 8 times 2, because 8 is a perfect cube. We got a 3 in front. The cube root of 8 is 2. And I got 2 left underneath. Multiply what's in front. And we get this. This one, let's split 54 apart. Now, perfect cube factor of 54 is 27. 27 times 2. I take the cubed root of the 27, which is 9. Got square root of 2 left over. Multiply those, we'll get 36. And notice they now match. This matches this. So we combine them together and we'll get this. This is not any harder. It's just going to involve simplifying first. If there's a number in front, you multiply it by the number you get when you take the root. That's about the only difference. So don't freak out over this stuff. This is pretty straightforward. But you've got to work on the simplifying part.